Welcome back, everyone. So today we will be doing and conquering, not conquering. We're going to be conquering antiderivatives today. So antiderivatives are basically indefinite integrals. It's like, gives you sort of like an introduction to indefinite integrals and that whole crazy integration section when you get to Calc 2 or if you're in Calc 1. It kind of prepares you, because it gives you like a heads up of what integration will be like. It's like opposite of derivatives, and it is. So, you know how like derivatives, you were giving, what's the derivative of x? It's just 1. It's going to be, what's the integral of 1 dx, which is just x plus c, because, you know, well, oh wait, yep, forgot. There's always something I forget, plus c. X cannot be, I just realized that, and I plus c. So, we're going to get to the formula for here. So the integral, this is the basic integral antiderivative formula. So the integral of x to some number n would equal, when you take the integral of this, be x to, I am forgetting a dx. I just realized that now. Oh god, I'm so crazy. Just dx equals x to the n plus 1. Okay, I got it. Dx, okay, alright. So it's going to be integral from x to x to the n times dx equals x, the integral, okay, of this, x, let's see, oh, I'm so crazy, so see now, x to the n plus 1 all over to the n plus 1, divided by n plus 1 plus c. So basically, what you're doing is you're taking this, so it's a power, and you're dividing this variable by your power. So that's what we're going to apply this. I don't like this word. This is not cute. Okay. Power. And we're going to be applying this rule to this and this. So let's first start off with number 1, because number 1, I think it's a good problem. I just want to find it. Let me see if this pen works. Oh, this is pretty. So, yeah, I'll use it. So it'll be the integral. This is too light, but I guess I'll just switch to purple because it's a pretty color. So it'll be 3x squared. You're going to add 1, and of course divide it by this power, which is 3. Actually, I'm going to put it down. 2 plus 1. So basically, essentially what you're doing is, so you're adding 1 to here, and then you're taking this, and you're going to divide it by, divide it by this variable. So you have a power, and you're going to divide this number, this thing, this expression, whatever, this variable, by the actually variable. Just follow this, and what I'm doing. Plus, we're going to switch this to x to the negative 1/2, because, this is going to be x to the negative 1/2. It is. And we're going to add 1, aka 2 over 2, all over negative 1/2 plus 2 over 2. You're going to divide it by negative 1/2 plus 2 over 2. So, basically, like I said, what you're doing is you have this to some sort of power, and then that's the first step. Then what you're going to do is you're going to divide it whatever you received from the power. So like for example, like with this part here, we have 3x, if you can do it in your head really quickly, 3x cubed. So you're going to divide 3x cubed by 3. That's just what the rule says. So we have x to the n plus 1 all divided by n plus 1. That's what we're doing here. It's basically divided, okay. So here, like I said, 3x is 2 plus 1. We're going to divide, this is our power. This is our power. And we're going to divide 3x. We're going to divide this 3x by this power, and so which is 3. Now I'm going to continue. So in the end, it'll equal 3x cubed over 3 plus, okay, so it's just 1/2, so it'll be 2 Yep. 2 over 1. Yep, 2 over 1. Times x to the positive 1/2 power. And so in the end, the integral you will have is 3x, actually, these are going to cancel, and you're going to have x cubed, these we're going to cancel, these are supposed to cancel, because, yeah, they do, plus 2 square root of x plus c. And the reason why you want to have that c there is because, like, before, let's say this is our, our c could be anything. Our c could be e, it could be 6, it could be 10, it could be 1,000,000, it could be 1,000, it could be anything. So remember, you need to add that c there to anything, whether you're doing partial fractions, if you do the integral of some weird partial fractions, you need to have plus c in the end. Always plus c. So we have plus c. And now we're going to do another one, which is, we're simple, it's polynomial. So that's what we're going to do again. So we're going to have the integral of x, do a prettier integral. You know what, I'm just going to start off from here, because I am not going to write it again. So we're going to add 1 to the top, and then we're going to divide it from whatever we got from this, whatever it sets to, whatever power it sets to according to this rule. So it'll be 2 plus 1, 3x 1 plus 1, all over 1 plus 1, 0 plus 1, because remember, this has no x term in front of it. This is just a number. So we're gonna so it's raised to the 0 power, and we're gonna add bit y by 1 all over 0 plus 1, and so we'll have in the end equals x cubed all over 3 plus 3x squared all over 2 plus 4x plus c. And that is how you take a basic integral. Basic antiderivative. So what we did here is, this is sort of, like I said, an introduction to indefinite integrals or antiderivatives. You will learn it when you're in calculus, and I'm sorry about talking fast. I love talking fast. So what we did, talk a little normal paced. So what we did was, for both, when you take an antiderivative, basically what you're doing is that you have, like, for example, like number 2, we have x, actually, let's do number 1, let's start off with number 1, okay? So we have 3x squared. So when we integrated it, we added 1 to its power, and also we divided from what was from the power. So we divided it by m plus 1, or in this case 2 plus 1. It's the rule, it's the formula. I didn't make it, someone made it. So, and that's what we did for here, and well, you should do the same for any other basic integral. So what I suggest to you is follow this formula a lot. You're given, let's say your teacher gives you a set of problems like this. Here's the thing, follow this formula forever, and you will get all your homework correct, and you'll get A+ on that homework. You just don't even need, help from her or your teacher, anyone. Or, just come to Concord Math, okay, and you can find out this. Just remember, follow this rule, and you will get it. Just follow this rule. And right at the top of your paper, do whatever. Just follow this rule, okay? Follow it. So, I hope I've conquered all your math problems today. And like and subscribe and comment down below what math problems I should help you on next. But for now, I hope I've conquered your math problems. So I'm gonna go now, and I'm gonna just stop this now. So bye.